So, final exam review number 2, the unit 2 exponential functions. All exponential functions take the form a times b, where a is your y-intercept, your starting amount, and b is your growth or decay rate or growth factor. Okay, so those are. Wait a second. And so this is an example of an exponential growth curve. Okay, all exponentials are curved lines. The y-intercept is where it crosses here, your starting point. Your next now statements are always in the form of next equals now times your b function plus your a. Okay, so next equals now times b plus a. Now I'll write that over here real quick. Times b starting at a. All right, number 1. So next now for each of the following situations. All right, so for these, we got to find the growth rate. We got to find a and b. Okay. All right. So to find this rate, what we'll do is we'll take 192 and divide it by 48. Okay, so what's 192 divided by 48? Somebody. Do it. 4. Okay, so this is 4. So it looks like our growth rate here is 4. So we're going to take this 2. We need to get back to 1 here. Okay, actually we need to get back to 0. Okay, we need to get back to 0. So take 48 divided by 4. That's 12. And then 12 divided by 4 is 3. So that's our a value there. Okay, so here, next equals now. Next equals now times 3, starting at 4. That would be our next now for A. All right, for B, okay, where do we start here? We'll take 18 divided by 6. Let me get what? Say again? That's 3. Okay, so that's 1. This is be 0. Okay, 6 divided by 3. This is 6 divided by 3. It's 2. Okay, 2 divided by 3. 2 divided by 3. Okay, 0.6. We'll call it 0.6. So here, next now will be next equals now times 0.6. Times 3. Starting at 0.6. All right, good. All right, part C. What's happening here? What's 20 divided by 10? 2. Okay, so work our way backwards. 10 divided by 2? 5. 5 divided by 2? 2.5. So our next now here, next equals now times 2, starting at 2.5. Okay, move right along. Okay, simplify the following expressions. We have no numbers floating above any parentheses here. Okay, nothing is floating above parentheses, so we can go right into multiplying. Okay, 3 times 2 is 6. Okay, x to the 2 plus 1, 3, y to the 7. Okay. So we have 6y to the third, 6x to the third, y to the 7th. Okay, part B, again, nothing floating above parentheses, so we can go right into it. Okay, 2 times 8? 16. 3 plus 4. 5 plus 7. 12. Okay, so 6x to the 7th, y to the 12th. Last one, we have 3 letters to deal with here. Again, nothing floating above nothing floating above the parentheses, so we can go right into it. 7 times 3, 21. X to the what? 12. Y to the 13th. Z to the 4th. Okay, so 21x to the 12th, y to the 13th, z to the 4th. Good? Hey, all right, so what function best fits this data? We need to do a comparison. Okay, so in our calculator, we'll have L1 and L2. So for the years, the way that we're going to take it is this is going to be years 0, 1, 2, and 3. Okay? So that's going to be 0, 1, 2, and 3. And then we end up with these stay the same. 998, 872, 756, and 658. Okay? So that's going to go in our table. Okay? I'm going to show that on the calculator. So which one best fits? And what is the correlation coefficient? Okay, so to check my correlation coefficient to see that it's on second catalog, I'm going to go all the way down to diagnostic. Make sure it's on. On. Okay. Now I'm going to go to stat, edit. My L1 is going to be 0, 1, 2, 3. So here I got 998, 872, 756, 658. Okay. Whoa. Rookie mistake. I didn't clear my list. All right, try it again. 998, 872, 756, 658. Okay. All right, so I need to compare linear to exponential. So I'm going to go stat calc 4. Okay. My R here for linear. Oh, wait a second. I'm in I got to change my mode real quick. Okay, so my R here is negative 0.998 for linear. So we have to remember that 0.998 for linear. And then stat calc 0. And this is 0.999. So this will be higher. Okay. So we're going to go with the exponential function. And that'll be the function here. So we're going to go with I'll rewrite the linear. The linear, the R value was So R equals 0.99, I think it was 99 something. We'll check that again. What was it, 0.996?
Yeah.
0.996. And then for exponential, R was 0.999. So we're going to go with exponential because it's higher. And so our function was y equals 999.55. We'll call that 999.6. Times 0.87 to the x power. 0.87, yep, to the x power. So we'll take that to be our function to match this situation. Okay, number 4, let's match the following graphs. So we have 4 scenarios here with these. So we have 2 exponentials and 2 linears. Let's take care of the linears first. All right, C appears to be going in what direction?
Down.
C is going down. So C is a linear that's going down. All right, so I would take that to be a linear decline. So this would be line C, a linear decline. And then, so line D, this is a linear that's going which way?
Up, down.
Up. That D is going up. So that's a linear growth. So that would be line D. Okay. Now we have exponential growth and exponential decay. Okay, which one's going up between A and B?
B.
B is going up, right? This is a curve that's going up for B. So I would call that exponential growth. And then A is going down. And that's exponential decay. So that's A, exponential decay. So that would be those 4, comparing those 4. Okay, example 5. Juan invests in a wealth program that starts with $800 and it grows by $150 per month. Marco invests in a wealth program that starts with $20 and his balance triples every month. How much more money will Marco have than Juan in 5 months? Okay. All right, comparing the 2 programs, what can we say about Juan's if it goes up by the same amount each month? Say what? If it goes up by the same amount each month, that's a what situation? We call that a what situation? It's going up by the same amount each month. Okay. Linear, right? Okay. So Juan's situation is linear. Okay. So that's y equals mx plus b. So what would Juan's equation be? Okay, so y equals 150 x plus 800. Okay, and Marco? All right, Marco's, his is exponential, right? Because it is triples. So that's an exponential function. He starts with $20 and his triples every month. Okay. All right, so what we need is plug in 5, because it's 5 months. That's an x equals 5 value. We'll plug that into each of the equations. So y equals 150 times 5 plus 800. Okay, so y equals, what's 150 times 5? 7, okay. 750 plus 800. What's that? What's 750 plus 800? 1550? Yeah. Okay. And over here we have y equals 20 times 3 to the 5th power. And what's 20 times 3 to the 5th power? It's what? 14,580. You sure? That's a big jump. 14,580. That's a big jump. I got 4860. Okay, so this is 4860. Okay, and then you'll subtract them. So, because it says how much more money will he have? So 4860 minus 1550. So 3310 is how much more. Okay, so you got to find both and subtract if you want to find out how much more that Marco will have than Juan. Okay. Is there an example 6? There's number 6? Okay. All right, I'll come back to this if you're still copying. All right, number 6. 6 is the last one. Okay, Juanita takes 400 milligrams of aspirin. The amount remaining in her bloodstream can be modeled by the function y equals 400 times 0.92x. Which of the following are true? So the practical domain for this situation is all real numbers. All right, so let's talk about the domain real quick. Okay, so our domain is our x values. Okay, and that's the x values. And in this case, it represents time. We're talking about a bloodstream situation where it's mapping the amount remaining in her bloodstream in time. So in this case, it's time. Okay, so can we have... Okay, so if she takes 400 milligrams of aspirin, like at 10 a.m., can you measure the aspirin in her system at 9 a.m.? Probably not. Okay, not from that same dose. So you can't go backwards in time. Okay, so is the practical domain for this situation is all real numbers? That's not true. Okay, it can't be all real numbers. It has to be positive numbers. Okay, so that first one's not true. The second one, this is a function. Is this a function?
No.
This right here, is this a function? Can we graph it, put it on the table, and look at it? Yeah, that is a function. Yes. Okay. And the practical and theoretical range for this situation is the same. Okay. The practical and theoretical range for this situation. Okay, so the theoretical range would include any possible range value, okay? The practical would only include 400 and below, okay? So that won't be true. The theoretical range would include negative values. So that, just like we can't have negative time, we can't have, if you graph this on a function, you can go backwards and get numbers that are above 400, okay? So that would not be true as well. Okay, so this is false. Okay, because the theoretical range would include numbers above 400. Okay. So that would be a false statement. Is that the last one?
Yes.
Okay.